Hello, this is solving exponential equations using logarithms, and this is for a pre-calculus class at the University of Texas, El Paso. We're going to solve an equation of 5x equals 16. We can solve this equation in three different but very similar ways. They are using the definition of the logarithm to rewrite in exponential form, then use the change of base formula to evaluate. We could instead take the logarithm base 5 of both sides using the power property, and then using the change of base formula we can evaluate. And finally, taking the common log, or natural logarithm if you prefer, of both sides using the power property and evaluating. Using the definition, 5x equals 16 can be rewritten as x is the power to which we raise 5 in order to get 16. In log notation, remember all the logarithm is just an exponent. So this is x is the power to which I raise 5 in order to get 16. In order to find a decimal approximation of this particular logarithm, we could use the log base command of a graphing calculator, or just use the change of base formula, remembering that it's log of 16 divided by log of the base. Log of the base goes in the denominator as the base is already written a little lower. Our decimal approximation will be 1.723. In the second method, we could once again start with 5 to the x equals 16, and this time take the base 5 logarithm of both sides. It really looks like we're just writing log base 5 in front of the 5 to the x, and log base 5 in front of the 16, and really that's all we're doing. Using the identity property, we can simplify the left-hand side. What power, the logarithm, do I raise 5 to in order to get 5 to the x power? That's exactly x. So we'll have x on the left, log base 5 of 16 on the right-hand side. This is the exact same answer as we had using the definition, but now we still need to know the change of base formula in order to get log base 5 of 16 is equal to log of 16 divided by log of 5, which is once again approximately 1.723 if we round to 3 decimal places. The third method, we can take the common log, or the natural log if you prefer, of both sides, and we no longer have to know our change of base formula. Once we take the log of both sides, which is writing log, common log, we don't write the base, in front of the 5 to the x and also in front of the 16, we will need to know the power property that takes this x and moves it to the front to get x log of 5 equals log of 16. Finish by isolating the variable to get x equals log of 16 divided by log of 5, once again approximately 1.723. This is a great method to use that'll work on any problem, especially if you have troubles remembering the change of base formula. That's it for solving exponential equations using logarithms.